going to be completely discuss about the interrupt. Okay. So after you understand what is interrupt and all this stuff, you make sure you can able to write a code for this. Okay, so how to configure one interrupt. So how you can able to understand the concept which is present inside it. So everything you can able to understand. Okay. So first we will discuss about what is an interrupt. So this is what we have to be study, and based on that we have to be study the lot of concept in that. Okay. So first of all, you people are know this concept. What is meant by interrupt? So you know that. So interrupt is a signal, one of the signal. It helps to temporarily halt the normal execution of a program and handle by the process to manage a urgent task. Because so you know that we know that the concept is so your processor can do the all functionality. Right, your processor, this is your complete microcontroller. So in this microcontroller, the very important thing is your processor because all the peripherals which is present in your microcontroller, that is your on chip. So all the peripherals are on chip. So if you are going to be taking any ADC, if you are going to be taking any timer, so all the modules are on chip. Okay, so that is the microcontroller we are going to be calling it. Okay, and a DAP, so I2Z, everything is there. Okay, so it is on chip memory, on chip. Okay, you can take any memory. Okay, so the complete thing is your processor started to continue this concept. Okay, so you just think it, guys, if you're going to be taking UART, you need to transmit and receive the data. So if you just using ADC, you have to be converting the analog signal to digital signal. So if you're going to be taking a timer, going to do the different thing. So a DAC, for example, it is really helpful for audio signal. Okay, you can able to hear the digital to analog data. I2C, with the help of this SD and SD line, we can do the communication. So memory, we are having the lot of memory like flash, SM kind of thing. So every peripherals which is on chip or microcontroller. Okay, so this microcontroller which is controller as on chip, so your processor plus other peripherals. Okay, so the processor can do the all the functionality like processing the data. So it does doing the very important things. Okay, so in this case, right, so you are having the multiple peripherals on the single chip. This is your microcontroller chip. Okay, so you just think about it. This is your chip. Okay, so in this time, you have to be configured. So what you're actually going to be doing, you are going to be interfacing. If you want to be convert from analog to digital data, you are going to be configuring the ADC. If you want to be convert the digital to analog data, you are going to be configure that. If you want to store the data, you are going to use memory. If you want to be count the signal, you are going to use timer. With the help of you, what you're transmitting or receiving the data, you are going to use. So these are the common functionality. But what is the purpose of interrupt? Okay, so interrupt is one of the special thing, like, so we are going to be configuring through any GPIO. Okay, so we are having a lot of varieties is there. I'm going to be discuss about that. Okay, about that also. Okay, so interrupt is one of the signal. Okay, here interrupt is one of the signal which can temporarily halt. For example, your processor just processes the data of analog to digital converter. That is the task it was given to them to convert the analog to digital data. That is the very important task for them. But just think about it. It is currently doing this function. But suddenly some problem which has happened into the microcontroller. So we are having a lot of problems gonna be happens. Okay. So you can consider it as a problems or any emergency task. Okay. So in emergency task, it just memory just has to be stored there. You have to be store the all the data to the memory. Okay. So we have to be suddenly store all the data to the memory. So it is going to be act as an so if your DAC can also act as an interrupt. So so you can also configure anything going to be act as an interrupt. Okay, so that is going to be called as an interrupt. So what this actually going to be doing is it just halt the current function. The interrupt can do the halt means just to stop. If it is processing the analog to digital conversion work, it just currently stop that work and move to that what was when was interrupt happened and where was interrupt happened. For example, we're just doing this analog to digital conversion process. It is in the processing work. Suddenly, the timer which just came as an in. Okay, you just consider it is going to be act as an interrupt because all peripheral can able to act as an interrupt. That time it just stop the ADC work. Just stop the ADC work and move to this timer and process the work, process the timer work. Once this work has been completed and move back to this ADC. So it is going to be do this process. So this is how the actual thing of actual thing of interrupt. Okay, so this is one thing. So once the interrupt is surfaced, the program resumes from where it was interrupted. Okay, so this is the main important thing. So you know this example. Okay, so for example, the chef work is to be cook. Okay, so the mandatory work is for to be cook. Okay, and for example, if the thing suddenly the fire alarm which has actually happened, so it just it just stop his current work. Okay, it just stop to cooking it. So and he just moved to this fire alarm where it was. He need to be sort out that problem, right? So he need to be clear out the problem. So for that, he just currently stopping his cooking work and move to this where the fire was happened. And after all cleared all the fires, he just back to this because the cook workers to be the chef workers to be cooked. Okay, but because of the emergency task has been allocated to her, so you can't skip that. So that is the interrupt. So when the interrupt has been happened, we can't neglect the interrupt. Okay, the processor never neglect the interrupt. So how the cook can't able to neglect the fire which has happened, because if he neglect this fire, so the severe damage, the severe disaster gonna be happen. Same thing if the interrupt has been neglected. Okay, so definitely it is causes some problem. Okay, so you have to be understand this concept. For example, you just see this one, your push button is wearing an LED toggle without continuously checking the button. Okay, so the example because I'm going to be tell the difference between the input and ONG. So that is the next important topic. Okay, so what is interrupt keys? Here, you just take this example. Here, cook. Okay, so here, cook or here, this is your okay, and here the fire alarm is happened. Okay, you just think it. The cook, okay, or the chef. The chef won't always looking for when the fire alarm is going to be happen. When the fire alarm is going to be happen. He won't check like he actually doing his current work of to going to be cook for the customers. Won't look for this fire alarm happened or not happened or when it is happened. When happened, he just do this work. Same thing. So the processor, you just consider the cook is a processor. Processor can do the normal works. When the interrupt work was called, then only just move to this interrupt. That is the actual interrupt. Okay, that is called exactly interrupt. Okay, and what about the polling weeks? Okay, what about the polling means? The polling is one of the another technique where processor continuously checks a peripheral or sensor for change in the state of instead of waiting for it. That means this is the cook and fire alarm. One of the example I just tell you that. And another example is, you just think that another example you can say for the security. Okay. Security for always checking for whether the fire alarm is happened on it. Okay. So this is fire alarm. Okay. So the security was allocated. The security was allocated, but always check. Okay, was allocated. It was allocated for the duty to checking whether the fire alarm is happening or not. So when the fire alarm is happening, you need to be sort out the problem. Okay, you need to be clear the problem. So it was specifically allocated for. This is called polling. Okay, so interrupt means like chef won't consider the fire alarm is happening or not. He will do his current work of cooking. So when it is happened, when there is no people out there, so it is going to be do there. So that's how the interrupt is going to be happen. Okay. So the polling is like your processor is always checking for the interrupt. Only for interrupt. Like whether it is happening or happening on. The sudden emergency task is coming. So this is the actual work of difference between the interrupt and okay. And so if you just see this one, the disadvantage. Because what are the disadvantages in polling is it will be wasting the CPU time. As it repeatedly check the signals because it is not actually going to be checked for any other task, whether that going to do any processing the data, so computing. No, it is not going to be checked. Always check for any interrupt task is happening. Any interrupt task is happening. So that is the main model. Okay. So not efficient for low power application. So it is not efficient. And function. Steps in polling is CPU executes the main program. After every few instructions inside the loop, it will be checked the flag register of a peripheral command. So check if UART's receiver flag is what, the data is very safe. If the flag is not set, CPU go back to continue main. If flag is set, CPU passes the main program and executes the receiving the continuous data. The very thing you need to be understand here is here we will see the conditions what they are actually trying to do. First of all, CPU executes an input. So we know that always the program starts from the main program. I mean main function. Okay. So here it is starting. The condition is check if UART's receiver flag is 1. So while you're going to be writing program for any microcontrollers, we are going to use this condition called flag. Okay, we just using one of the variable. So because all the microcontroller which is holding specific register, okay, each which is having different type of register. So for transmit, you have to use one register. Okay, when that data is going to be transmitted from one device to another device, it is going to be checked the buffer is clear. For that, we are going to use another register. Okay, whether it is received or not. So for that, we are going to be another register. Okay, so in this condition, when the data has been received, you just set this flag as that means RS flag is going. So that time when you're going to receive the data, that means that time you are going to be convert the RX flag is going to be made. So these are all the conditions we are going to make sure right in the program. Okay, if you have received the data by using the AND operator, so we are going to be write the condition. Okay, we have to write based on the condition syntax you are going to use. Okay, so this time it is always going to be checked. So once the receiver flag going to be set, it is data has to be set. So flag is not set, the CPU go back to the continuing. So in this main function, it is set for the whether the receiver bit is set up. If you just think about it, if it is returned in this main function, it is always going to be do this function. It is always going to be check this function. Okay. So when the flag is set, it is going to be doing this current. Okay, it is going to be all reading the data. Okay, when the flag is settled, if you have been receiving the data and reading the data, then it continues. So the main scenario is If it is the polling technique, it will be wasting the CPU time. Because of it, always check whether the bit is settled, whether the data has been received or not. So this is what the main task for this polling. So it is not good for that. Okay. And what is the difference, main difference between the polling and interrupts are? You just see this very good example. Polling, button pressed using polling and the button pressed using interrupt. So you just see this one. I'm having one button. Okay. So here I'm having a button. Okay. When the button is pressed, okay, I'm going to press the button based on the polling technique and based on this interrupt. Okay. So until we are running this code, okay, so it is going to be happen. Okay. So that is based on whether you are going to be using a polling technique or the interrupt technique. So you are having one push button. You are having one button. You are going to be make sure you are going to be do one method is polling and another method is interrupt. We already did the project based on the polling. We already completed the project based on the polling. Okay. Yes, it is always going to be checked whether it is happened or not. So in this condition, so if I'm going to be open this polling technique, you just simply see this polling which just having they have been initialized one button. Okay, if I'm going to be using one peripheral as button, it is definitely connected on GPU. For that, I've been used on GPU. Okay? When the button pressed, you have to be blink the LED. This is the lot. This is the task which I am given to you. Okay, but you are going to be do both the concept. Okay, in both the concept, like by polling method and by interrupt method. Okay. So when I'm going to be do by the polling method, what will be happen when I'm going to do the interrupt method? What when I've just simply pressed the button. Okay. So there it is going to be. But if you are just seeing this here, I've returned while one. While one means it is infinite. That means infinite times it is going to be execute the task. Okay, until you are going to be stop the specific thing, it is infinite time. It is going to be repeatedly going to be doing this, checking this condition. Okay, if you just see this one, while one means infinite. Here I've been written button press. So this is one of the macro. And the pin I've been used, some other pin I've been port F0 pin I've been used to be read the data from the user to check the button condition. If it is pressed, you just blink the LED, toggle the LED. I'm going to be write as a specific function definition. Okay. So it is always going to be checked. Wait for the button as being pressed on. Okay. So I've been returned on this while one. So how polling code is actually working? So the processor runs the infinite time while one means it is continuously checking the button status. If button is pressed, it toggles it. The processor stays busy checking the button when it is not pressed. So the actual work of this is it is always going to be checked by the user side whether it is pressed or not pressed on. Come on. Thank you guys. Thank you for all the while. Okay. So voice is lagging. Some people are telling me. Please, I don't know what's okay. So guys, some people are asking the questions like when to use the interrupt and when to use the polling. Okay. So the good question. So we will see this one. So there is the two things is there. When we are going to be using the interrupt and when we are going to be use the polling. Okay. Polling means whenever you are having a task, okay, that is for to be continuously checking. Okay. For example, we have been previously write one. Okay, we have been previously write one code. So if, while I'm going to be show that. Okay. That is the project which we have been done. In that project, I've been taught about the UART transmitter. I don't know how many people have been remember that concept. So in that UART transmitter, when I'm going to transmit the data, when the transmitter bit has been set, okay, when the transmitter bit has been set, so it is going to be, we have been do one thing. So if it is the data has been received, so it is always going to be checked. Okay, so we are having a two devices. So we just having a two devices. One is for to be, like, I'm just simply telling this one. Okay. So what I did on that time is the project which you had did is I'm simply explaining it. Okay. So two microcontroller we have been taken. One is STM32 and another one is the Arduino. Okay. So in this time, what we have been did is we have to be transmit one data. I think I've been sent hello world for embedded developers. Somewhat the data we have been sent from STM32 to Arduino or some character we have been sent, right? Some character which we have been sent to the devices. Okay. So on that time, when I'm going to be transmitted the data, in that we have been written one condition because the buffer should be free. While in the system that I do, if you are transmitting the data, it always check the buffer is free or not. So when the buffer is free, it will be transmit the data. For that, we are having a specific register for TXC. When the transmitted buffer is free. If it is free, send the data. If it is not free, don't send the data. Same for if you are trying to receive the data, you have to be checked for the receiving buffer. Okay, it need to be checked whether the receiving buffer is having any data or you are going to be checked and then only you can able to receive it. For this condition, guys, you can use the polling. So it is actually using a polling method. Like while you simply write, you have to return the condition. Right? When the transmitter buffer is free, you just send this character. Okay. So what it is actually going to be do until your buffer is free, it owns in the data. It owns in the data. Okay. When the buffer is free, it is also this condition, it is always going to be checked. It is always going to be checking the condition. So when the buffer is getting free. If it is not free, it is not going to be checking the data. So here it just acting as a polling technique. So in this your project, so here you can simply see this. This is one of the examples. Okay. Because if you're configuring polling or interrupt, you're going to be using that interrupt functions. Okay. But here it is not exactly the polling. Okay. But you have to be use the interrupt registers for to even you're going to configure. So this is how it is actually going to be. Okay. For example, what you're actually giving. So while you are using a status register. In that status register, the TXC means receiver buffer is empty or so if it is empty, you're just checking with this register value plus you're trying to set the bit. So what it actually going to be fulfilled? It is previously the bit will be 0, 0. So you are trying to set the bit 1. Okay. So it should be become 1. Okay. And this become 1. So when you're going to do this logic, when you're getting 1 the output, then only just send the data. Okay. It is going to be sent to the data which have been given through DR register, data register. So this is how the polling will be acted. But here we have not used the polling kind of register. The interrupt registers we have been not used here. So this is one of the examples. This is how it is actually done. Okay. So and yes. And what about the interrupt? What about the interrupt? Is the button pressed. So here this condition is just simply take it. Here what we have been did is this is the LED. LED, some other GPU open have been taken. Okay. And another thing is for interrupt I have been written some other function. What is actually going to be doing this? Here, it just come to this main function. Here it is NVIC function has been called. Okay, okay, it has been called here. And it just come to this while one of continuously doing some other function. Okay, so main loop continuously executing other task while the interrupt is. So when the interrupt has been occurred, okay, when you are trying to be interrupt with help of this port of 0. So it is also telling that port of 0 is an interrupt pin. You have been configured by using interrupt registers. That is EXTI. So this is one of the register which you are going to be used for the interrupt register in extended domain. Okay, it is going to be varies for microcontroller to microcontroller. You have to read it by the reference number. So this one, we are simply configure port A0 is going to be act as an interrupt. Okay, when you're triggering that port A0, then only it is going to be reactive. So then only this function is going to be called and blink tell you. Until unless it won't go to that function, it is continuously doing the current activity of doing this function, some other functionality. Okay. And this is the interrupt and this is the polling. So how the interrupt code is actually going to be works. Microcontroller doesn't check the button is pressed continuously. When the button is pressed, the processor automatically passes the current and jump to the key registers. So the LED toggles, the interrupt flag going to be cleared. The processor resumes its previous task without wasting the time and polling. Okay. This is how the polling and interrupt is going to be happening. The polling means this is how the polling is there. Okay. Right? When the button is pressed, okay, it is always going to be checked. No key has been pressed. The polling is going to be happen. It just come to this condition. No key has been pressed. It is again going to be checked. So do key is pressed or not. Okay, the polling simply just understand. Polling is coming. You just check the condition whether the button is pressed or not. No key has been pressed. Again going to be checked. So again the polling is reacting. No key pressed. Checking the condition. Okay, checking the condition. No press. So when the press, it is going to be active. If it is no. So interrupt, if you just see this interrupt is simply coming. So the processor is doing some other channel. Here you're just considering it is a processor. It is not doing any functions. That's what it's not. The processor is doing some other function. When the interrupt is coming, okay, already doing some other function. This is one. And when the interrupt is coming, this is 2. And it just responds to the interrupt, it is 3. And move back to this original block, this 4. Okay, this is how the scenario is actually happens. Okay, and then we are going to be seeing the types of interrupts today. Okay, so what are the types of? There is a 3 types of interrupts based on source, based on processing, based on trigger mechanism. What is based on sources are? First of all, there is a 2 types of based on source means what? Any other material. So simply just understand it is one of the in terms of our microcontroller. So we have to be tell any peripherals as a source. Okay, it could be any peripherals. So what are the things which can able to act as an interrupt at all? That also. Okay. So in this time, what we can do it or what we are going to be do on here is we are going to be do the 2 types of one is the internal interrupt, another one is the external. We are going to be configure 2 types of internal and external. What is external? What is internal? Is external are completely external from the microcontroller. Okay, externals are completely away from the microcontroller. So these are the internal. Think that your GPA move and the timers. So some of the thing you can configuring as an external. So triggered by external devices, push buttons and such. Okay, and internals are generated by the peripheral inside your microcontroller. Timer overflows or ADC connections are internal. So here we will clearly see this internal and external peripherals. For externals are it's completely external sources. Like if you are trying to bring one new sensor, for example, LM35 sensor, yes, it is external. Internal. If you should configure it as internal, it is internal. Your GPIO, you are bringing any timer externally, it is act as an external internal. Okay, these are external. If you just see this, what are internal interrupts are? The internal interrupts are here. We have to be converted the analog to digital conversion. Okay, once the we have just simply give them analog data. Okay, analog data. So we are going to be soon see the hands-on on ABC. So then you can able to understand clearly. So once the analog signal has been completed, converted into the digital, it will be give one rate. Okay, that is the internal. So ADC conversion has been completed. That is act as an internet. For example, he previously studied the time. In that time, we have been using preload the okay, for auto renewal value. So like we have to be automatically reload the like once we are just using the we have to be count from 0 to 999. Once this 999 has been reached, once the 999 has been reached, we just give 100 because it just again move back to start to count from 0. So this is one of the internal things. So these are the very minor internal interrupts, not that much. We are going to be considered this. Okay, but these all the things also considered as an interrupt. Okay, and you are received completed. So when the UR has been received, okay, it is flagged. That one flag has been set. The data has been received. It is one of the small entity. So these are the things are internal. Okay, and that's it. That's it. So we have been studying most of the concepts. And then based on processing. So what processing based on processing? Maskable interest and unmaskability. So what are the things are maskable and what are the things are non-maskable things? So you just open up the reference manual and open up the page of interrupts and events. Okay. In this interrupts and events, if you just open up this one, they have been provided one vector table. What is mean by vector table? It is present in every microcontroller. This is the vector table which is having the all peripheral interrupt address. Like the flow which I already told you that this is the thing. Your processor doing some work. This is your interrupt. Okay. So this is your processor, ADC, and this is the timer. Okay. So the ADC is normal function and timer is the interrupt. If you're trying to configure, we're just processing the data. Then the timer is coming as an interrupt. So the processor is going to this timer one. So the timer which is holding some other address for interrupt timer address. So that is, we are just look out here. You can able to say timer one up to 10. So each which is holding a different. So where it actually going to go? The processor just to go to the address of this timer interrupt address. So which is 0 cross 0 0 0. If this is the vector table SP. Once it has been completed, just come back to this original position. Okay. Got clear? Okay. So the maskable interrupt. So what is meant by maskable? So the maskable interrupts are you can able to enable or disable it. Okay. If you don't do, if you want to be enabled on GPU, you have been did projects. And that if you want to be enabled on GPIO, then enable. It is going to be you are doing by software. If you are if I want to be blink the LED, which is present GPIO of fifth pin, you just use one ODR register of fifth pin whenever you one on, 0 off. You can able to do by the register itself by writing a code by using software. that all things are maskable. Maskable. Non-maskable things are you cannot disable or have a highest priority. Just think about it. Your microcontroller get failure. Could you do anything by using software? Your watchdog timer is getting expiring. You have to be bring new watchdog timer or you need to be change the battery inside. So these are the things which just happen hardware based. These are software based. So even you just see this one, this input table. The first three things are the three things. So here I've been given that the four. These are the non-maskable. Okay, these are the things are non-maskable invariant. Here, first of all, reset. So whenever your microcontroller get powered on, automatically it will get reset. That is having one register. I mean, address. So a non-maskable interrupt. So clocks security system. So it is you cannot fix it. You cannot fix it. So hard fault interrupt. So one day we will study about what is meant by fault, what is meant by management, memory management fault, what is meant bus fault, what is my usage fault. So each which is having a different thing. Okay, if you just see this one, sometimes we are going to be right in the code, like 0 divided by 3 divided by 0. What will be the answer, guys? So let me check. All the people are aware of. Sorry, people are listening beyond. So what is the value? What is the answer for 3 divided by 0? So can you give the answer for this one? What is the answer for 3 divided by 0? So everyone gonna be answer for this one. Yes. It is undefined or it is infinite. Okay, it is a infinite. I'm not asking 0 divided by 3. I'm asking 3 divided by 0. Okay, so the value is infinity. Okay, the microcontroller only knows the value called as a 0. It doesn't know infinity. So this is one of the fault. Okay, if you're writing a program based on the 0, 3 number divided by 0, anything divided by 0, this is going to be considered as infinity. It is one of the usage like that. It is what you must do. In some cases, if you are being mismatched with address, because each which is having a different address. Your GPO ones which is having different address. If you are being mismatching the address, it is going to be considered as one of the address. So the memory management, so bus fault address. So likewise, these are the very hazardous non-maskable interrupts. Okay. Other than this, if you just start from here, text and graph. So these are the maskable. You can easily quantify. Okay. And finally, based on trigger mechanics. Trigger mechanisms are level trigger and edge trigger. Level triggers are. So when the signal is remains high or low, you're going to be receiving data. So previously I told you that, but now we will take one ultrasonic sense. Or IR sensor is a very good example because it is having only one data bit. Okay. So in this IR sensor, we are simply we just having a two one is IR, okay, infrared, then another one is LED. So what is actually going to do? One is going to be emitting the infrared. When the object is there, just eat into that object and reflect it back. Based on that, whether the object is there or not. If it is that, you just return to this code. If it is there, you just give one, set one. If it is not there, you just simply sit. So when so you just simply configure when the signal is going high, then causing an interrupt. The signal is 0, don't pass. Or else you just do it at full time. Okay, that is also going to be fine. Okay, so then edge triggered interrupt. So what does mean by edge triggered interrupts? So triggered on rising high or so here you just consider pi. So, the edge triggered interrupt. That means here it is completely the level based. Okay, it is completely the level, whether it is high level or low level. Okay, here this logic is considered the level, high or low. But when it is in the edge trigger, it just consider the state. So from falling to low state, that means high to low state, low to high state. So in data, in when we have to study about I2C or SBI, what we have been said, when the data pin getting high to low, when the clock is getting high, low to high, start the communication. So what it means here, it is called as a level. We are just speaking about the state level. So from which state to which state, while it is going, it need to be start the communication. You need to be send the data, transmit the data. Okay. So in these method also you can configure in the interrupt. And then we have to be see the how interrupt is actually between works. So simply I'm going to be telling this one. Interrupt is going to be happening. Okay. For example, interrupt is happened by pressed one button. Okay. Just simply okay, we just simply having one button, you just simply press the button. When you only press the button, the microcontroller has the main one. So processor, you're having a microcontroller can do some other task, the processing the data. So currently just halt the work and move to this. So what do you mean by ISR? It is an interrupt service. Okay, so interrupt service means each interrupt which is holding an address that is present in the vector table. Okay, so ISR means we just move to that address when the timer is just calling. When the push button is calling with the help of the GPIO pin. Okay, GPIO which is having a specific register name of XG. Okay, so when it is called, just go to this address. Just go to this step. And after the ISR has been executed, for example, when you are triggering this button, you have to blink the. So ISR execute the turn on the energy. So once the ISR has been happened, it just resume back to this action. So this is the actual thing. So main code execute, interrupt occurs, ISR execution, move to this. Just simply take a screenshot also, easily remember for that. So this is your main program happened. So when the ISR happened, you just first of all check the vector table for to be go to the address, right? So if you want to be go to this any new country or any new state to meet your friend, definitely you know the address, you know the landmarks. Definitely you know the address exactly, then only you can reach that specific place. So before going to reach the ISR work, it need to know the what address. If the timer has been called, know the address of time. When the timer address has been get, after I just move to this location. Okay, move to that location, and once it has been completed, move back to this normal. Okay, and then we are going to be learn about what is ISR exactly. Okay, what is ISR exactly? First of all, ISR is a interrupt service. It is one of the special function in interest. Okay, so it automatically when the interrupt is going to be active. So it is the vector table. So it just holding the vector table to store the memory that holds the address of this ISR for different interrupts. And again, I'm telling you. So if you just see this I2C3 KB, I2C3 address is different in normal configuration. Normally, if you want to be sending and receiving the data, it is different. If you specifically configure I2C3 need to be act as an interrupt, you are going to use this address. It is going to be use this address in this position and this priority numbers of. So it need to be checked the vector table. This is the vector table. Okay. And this one, we go to this work. So each interrupt which is having a unique entry in the yes, exactly. Each which is having a unique address. So when interrupt occurs, the processor reads the table to find correct ISR. The processor jump to the ISR and execute it. So when the interrupt has been occurred, it just exactly check the vector table and which ISR has been interrupt service routine need to be done. So you just check the address and go to this. That is the address. Okay. So I'll jump to this and complete the process. Example, the vector table structure I'm just showing you right now. And how does the vector table actually work? So when the vector table interrupt occurred, the processor look out the vector table to find this. For example, external interrupt occurred. So again I'm telling your GPIO pins, which is having a interrupt. If you want to be configuring a GPIO pins as an interrupt, you need to use the register called as an external interrupt. So you need to be checked that this external interrupt of 10. Here, the external interrupt of 10, it need to be checked the address. What is the address? What is the position? What is the priority number? Need to be checked all the things. Okay. And it jumps to the ISR function stored in the address. And ISR runs and clears the flags and the processor turns the function. So once it has been called, it just go to this address. Okay. So this is the ISR. Okay, and what is the summary of this concept is the vector table stores the ISR function, the processor reads the vector table, and it just go to this and move back to this original condition. Okay, so that is the thing completely. Now we are going to be discuss about the very important thing of nested. What does mean by nested? So we call it as an NVIC. Okay, so we call it as nested vector interrupt service. Okay, so this nested interrupts allows higher priority interrupt execute even lower priority ISR is running. What it is actually mean is, so we'll see this continue line by. So I'm having a step. First of all, NVIC is one of the peripheral of the cortex M. So, okay, if you just see the NVIC is present in the processor. Where it is actually presented, NVIC present in the processor. Just open up the data sheet. Okay, if you just see this, NVIC is present in the processor because these are the peripherals completely called as a controller. But this is your processor, right? This is your processor. Inside this processor, we are having an NVIC. What is meant by NVIC? What is the function of NVIC? Okay, so this NVIC is just having a 240 internal. 240 internal. So clearly, I'm just telling this. NPIC means it is a nested vector interrupt service. So initially, you're having one micro, a controller inside the processor is doing some function. Here, this is a processor, and this is your microcontroller. And this is the aids. Okay. Initially, the processor just processing the data of analog to digital, converting data. Suddenly, the timer which came as an input. So this is the time. Okay, this is the time. What it is actually going to be do? What it is actually going to be do? So it just hide this function, hide this work, and to go to this timer. And when it is completed, just move back to this is the normal input. This is the normal input. But if it is a NVIC, nested vector interrupt service, it's in the condition you just having the multiple interrupt trying to interrupt at the same time. For example, you are having another interrupt of use. Okay, you are having a another interrupt of user. User is another interrupt, and you just taking a I2C is coming another interrupt, and a tag is another interrupt, and another GPIO pin. is another interrupt. So at the same time, you got the multiple interrupt, totally 5 interrupt just. What you will, what you will. So this time, instead of you just having multiple interrupt as we, this time you can implement the NVIC. So what is meant by NVIC is based on the priority exact. Based on the priority number, you can prioritizing the task. For example, the timer which has K, user, I2C, DAC, and GPIO has been K. Okay. So here I've just randomly put the priority number. You just see this. The priority number of interrupt GPIO open is 13. Okay. It is the priority number of 13. And we'll consider DMA. It is 18. Instead of that, will consider DMA. This priority number is 18. And timer 2 will consider this the priority number of 35. And I2C we will consider the 38. Use that one we will consider a 41, 44. And I'm randomly taking, guys, don't consider 25. ADC is 20. So I just simply add the priority number. Based on the priority number, we are going to set it. So this time, microcontroller will be check the priority number. Checking the priority number, which is having the less number having high priority. If you just see this one, which is having a less priority number, which one which is having less priority number? Obviously GPIO. So the processor will do, even though ADC came first, even the USART came second. Don't consider this. Even though whoever came last, so you just think it, GPIO came at last. You don't consider the priority number. So it will be give the higher priority to this. So and then it just give the priority to this user because it is 80. And then do the function of ADC. And then do this. So you just take this very good example. First of all, you are having currently the ADC is actually processing the data. Suddenly timer came and user came, IDC came. So you just halt and see the priority number. Okay. See the priority number by GPIO is having a higher priority. First of all, just complete this work. And then it is having a higher priority. And it is having a higher. So by this work, by the priority number, it is complete the task. Okay. So, but other things, so if you may ask this question, then where other peripheral, where other interrupt are going to be stored? It is going to be stored in the pending register. Okay. So using NVIC enabling or disabling and depending various interrupts and read the status of the active and pending. Okay, because of this pending register, you can also have the different registers in the interrupt guys. We have to be study this concept. So when the process, because the process doing some other work, whether it is actively processing or the interrupt is in the pending status, so all the thing is going to be varies. We need to be check all those conditions. Okay, you're configuring the priority by the priority grouping interrupt. So it is called as a nested vector interrupt. Okay, so this is how it is actually going to do. Okay, yes, it's actually it's not a free atlas, guys. It is not exactly the free atlas, but it's act as it will be looks like a based on the, but it is like the same. Okay, so in this our task, it is time constraint one. We need to be complete the task in specific time. Okay, here it is the based on the priority emergency task. It is meant. If you just see this one, if a timer interrupt priority two is currently running, okay, but you are K, that is the priority number of interrupt, or the ISR passes and it just priority given to the use. So interrupt priorities are some interrupts are more critical than others. So it need to be held. So which one is having a higher? Okay. So STM32 interrupts source and routing. That means so clock security system. So I already told you what are the non-maskable elements. Cannot change it. So you cannot like external clock resources. If external clock failure, for example, your clock gate failure. Okay. So these are the things are causing a non-maskable data. Okay. We cannot change it by the software. Peripheral interrupt. That means you're just configuring UART or ADC timer. So these are the things you're trying to configure as a this and all. It is a peripheral. By using a GPIO pins, it is called as a GPIO. Okay. So this time, if you want your GPIO pins directly cannot connect with the NVIC because it is in the processes. Okay, so first of all, they will directly go to this external interrupt. Through that, we can able to use this external NVIC. Okay, so you just see this NVIC, which is present inside this processor side. So if you want to be work on, if you just use this NVIC, how can you able to turn that? With the help of this external interrupt. So this is a GPIO open. GPIO open, it is having a register of external interrupt, external register controller, and through that only you can able to catch this NVIs. But other peripherals are can directly do this. If you CSS, there is a clock failures and all which is happening, which it is directly connected with that. Your peripherals, ADC, timers, and all going to be yes, it can do. But external in GPIO opens want to be configured, you need to be connected with the external interrupt through that GPIO. So what are the key terms you need to be understand here? Expressions. Okay. So what does mean by expression means? So enable or disable mean to need to understand exception handling. So the exception handling means so enabling or disabling. So the exception can be triggered by handle or disable. So you can able to do handle or disable. Okay. By pending the request from the exception or waiting can be handled. So not pending means there is no request has been handled. Active means active or inactive means currently which is happening. Non-active means it is not. Okay. So what we need to be understand primarily here it is. So first of all, exception means it is like the interrupt. In other terms of interrupt is called as an exception. Both are having same. In name only, it's just doing. Okay, exception or interrupt we can call this. So enabled or disabled, you can able to enable or disable your exception, like your interrupt. Okay. Pending or not pending means if you are doing some other work, if any task has been rising, it's just putting in the pending register. If there is no has been raised, you just put it on the non-pending. Likewise, if your processor is just having any other task which is currently doing, it just telling current processor is currently active, just processing some other data. All the thing We are just simply studying means we don't do in hands-on. If you ask this question, no, we have to be do it all present in the registers, guys. If you just read this one, every registers, okay, we have to be study this external registers and we have to be study about all those things. Okay, what about the pending register? So if you are currently doing put it on the pending state register, you have to be doing so everything. You have to be read the radar sheet also. Okay. And finally, exception handling and preemption exclude. So we are going to be study this one. So pending state is a priority state. So what is it by pending and priority state are? When multiple exceptions going to occur. So that is the example I told you, right? So for example, when a multiple exception is created, again I'm telling the interrupt is going to be same in other name we call it as an exception. Processor, multiple exception which is happening. What is actually going to do? Lower priority ISR will be remains on the pending state as long as higher priority is going to be added. So then the interrupt, that exception which is creating, the processor which is doing the lower priority task of 5, but the higher priority task has been arise, means it just hide this shift and move to this. So when it is hard, you just put this task on the pending register. Okay, and this going to be act as an active state. Once it has been completed, move back to this function or any other higher priority task, you just move to this. So until other task which is present in the pending register. So other task will be in the active register. Okay, only no higher priority task is running, then only the lower priority task is going to be taken place. Okay, so what is meant by preemption? What does mean by preemption? Preemption happens when the exception interrupts the currently running task. This is usually done when the exception is having high priority. In this case, the currently running instruction or exception is put into the inactive state. The processor runs or jumps to the handle the higher priority exception. For example, this is called as a tail chain, guys. So this is the base CPU. Okay, this CPU, this is the interrupt one, interrupt. So currently, what is actually going to be do? The processor is just waiting. First of all, interrupt one is called. So suddenly, interrupt two is given higher priority. Just do this function, and then move to this function, and then move to this function. This is how it is actually going to happen. So what we can do for the equal priority act? Okay. So when you are just having a multiple exceptions actually happen. Okay. When you are having multiple exceptions, just all having the same priority. Okay. All having a same priority number. What can we do? Okay. So you just do the deterministic behavior by the priority. So in while we are going to study about the free task, we are having another tricks like round robin technique. Right? So the round robin technique, which will be help you to be both as came as an interrupt, both are coming. You just split the task by time. You can do the 1 millisecond, you just do the, but it is the interrupt. In interrupt, you want as came, 2 times are trying to be configured. Okay, this time what will be happen to do both are same priority number. Which one in the critical level? So it is giving the first priority to them. Restriction and activation. So once the exception is active and being handled, only the exception with a higher priority is going to be preempt. Until unless it won't do the preempt. Preempt means if one task has been happened on the processor, so when other task is trying to be stop the current work, that is called as a, this is preempt, this one, this preempt, this one. This is called as a preemptive. Okay, we just stop this function and trying to involve. That is called as a preemptive. So got clear, guys? Up to got clear? And finally, we are going to be studying about the tail chaining. What does mean by tail chaining? Normally, interrupt has been happened. The NVIC going to jump to the ISR. When the ISR has been done, control returns to the main. Just move back to this main part. With tail chaining, what will be happens is when the interrupt has been occurred, NVIC jumps to this ISR. Okay. Before returning to the main program, NVIC check whether if another pending interrupt is there. Okay. If yes, new interrupt has equal priority, NVIC does not return to the main function. Instead, immediately jump to the next ISR. Okay. Continuously, it is going to be happens. So simple thing is, we just see this. This is your processor doing some work, main function. Interrupt has been happened. It just stop this function, go to this interrupt. It just go to the size that is interrupt service return. Okay. So it is actually doing this function. Once it has completed, it does not actually go to this, move back to this function. All again going to check whether any interrupt which is present in this pending register or not. Okay, if it is there, it is completed and then only just move back to this. If multiple interrupt which is present in this pending register, once it just complete all the pending register, all the interrupt has been completed, move back to this processes. This technique is called as a tail chain. Tail chain means continuously it is act as a tail chain loop. Not exactly loop. It is like a tail chain. Once all has been completed, just move to this main function. Okay. So that is the thing. So today we have been completely discussed about what is interrupt, what is polling, and what is the difference between interrupt and polling. What are the types of interrupts can able to occur, and how interrupt is actually working, and what is meant by ISR, and what is NVIC, nested vector interrupt service written, and finally, what are the key terms which is present in the NVIC, and both in interrupts and exceptions or exception handler, we already call it as, or say. Okay.